Hey everyone, welcome to day 5 of our derivatives and integrals challenge. So today for the derivative, we have this equation that is going to lend itself to implicit differentiation. And then we're going to use a little trig identity to integrate this one by u substitution. Again, I recommend that you pause and try them out for yourself and then see if we have the same answer. So for the first one, let's differentiate implicitly. So for the first term, we are going to have, so the derivative of e to the xy is going to be, that's going to be the derivative of the top times e to the xy. So the derivative of the top is going to mean a product rule. So that'll mean the derivative of x times y. So that's 1 times y plus x times the derivative of y. The derivative of y is going to be dy dx, right? Which is really what we're after. And so that'll be plus x times the derivative of y, which is dy dx. And that's the derivative of the exponent, so that multiplies up front, and then e to the xy remains as it was. Next, we're going to differentiate this next term, which is only in terms of x, so that's simple enough. That's going to be 1 over 2x times 2, right? 2's are going to cancel out. Sorry, times the derivative of 2x, which is 2, right? And then on the other side, if we differentiate this term in y with respect to x, so that'll mean the same differentiation rule. So y squared becomes 2y, but we have to multiply that by dy dx because we're differentiating with respect to x after all. So now let's try to clean this up. So we want the derivative, right? We want our dy dx. That means that we have to collect all of the dy dx terms, kind of like we isolate a variable since grade 7 or so. And so let's multiply through this, and then we want to get all the dy dx terms on one side, factor it, and isolate it so that we can get an expression for it. So on this left-hand side, we're going to have y times e to the xy plus x e to the xy dy dx plus the 2's cancel out, so plus 1 over x. And that's going to be equal to 2y dy dx. And again, we are after dy dx in the end, so let's put it all on one side. Let's get every term that does not have a dy dx part of it. On the other side, factor, isolate, doink. So I'll move that over here and these two terms on the right-hand side. So I'll have x e to the xy. Holy camoly. Let's not let things get out of hand here. xy dy dx. Let's subtract, so minus 2y dy dx. And then we'll put these two terms on the other side, so that'll be negative. I'll do negative y e to the xy plus 1 over x, right? I'll just put a negative on all of it, keep things simple. Now we're going to have to factor out the dy dx on the left-hand side, so we'll have dy dx times x e to the xy minus 2y, and that'll be negative y e to the xy plus 1 over x. And finally, we can divide both sides by this expression. And so, all right, let's try to write it down here. So then dy dx, our derivative, after all, is going to be, I'll get rid of the negative and just switch the sign on both of these. So I'll just switch the order. And so I'll have y e to the xy plus 1 over x all over 2y minus x e to the xy. And here is our derivative dy dx. That was a nice one. For this one, this looks a bit wonky at first, but it's just lending itself really nicely to a u substitution. So if we pick u to be, again, I made it to be this way, sine squared x. If u is sine squared x, I'm guessing you're leaning towards making u sine of x. You can try it, it's just not quite going to work out. Actually, maybe it will. Maybe we'll try that way after. I was thinking of letting u be sine squared of x, because that would make du, using the chain rule, 2 sine x cos x dx. And if you'll remember, sine 2x as a trig identity is exactly 2 sine x cos x. And so that means that our integral becomes the integral of sine squared x is u, and then sine 2x is 2 sine x cos x times dx is just du. And so all we get is this. And so we can integrate that with respect to u. So that'll be u squared over 2 plus c. And then we can go back. And so we have sine squared x squared. So that'll mean sine 4x over 2 plus c. And this is our final answer. Now I'm really curious. Let's just explore here, since hopefully I have your attention for a moment. What if we make u be simply sine of x? Let's see how that plays out. If we let u be simply sine of x, then that means du is going to be cos x dx. And so we can now write our integral as the integral of sine 2x, I'll just remind you, is 2 sine x cos x. And so we can bring that 2 out front, right? And then we have sine squared x times sine x, which is sine cubed x. And so since u is sine x, that would mean u cubed. I think this will work. And then the cos x dx portion is taken care of by our du. And so that works out really well. We get the 2 out front, and so we have 2 times the integral of that with respect to u is u to the 4 over 4 plus c. And now we can rebring x back into the mix, and 2 over 4 is 1 over 2. And so u to the 4 means sine of x to the power of 4, which we know we write as sine to the 4 of x. 2 over 4 simplifies to 1 over 2, plus our integrating constant c. And so we get the exact same result. So that's cool. We have options. What do you know? That's it for today. Thank you so much for watching. If you guys have good questions that you think would make for a good video, please let me know in the comments below. And I hope this was helpful. Thanks for watching.